So this slide was motivated by my boss. He's always telling me, how can I summarize myself in one page, in a one PowerPoint slide? So is this the slider? Okay, good. So like she said, I put a soccer ball here because I play soccer throughout the whole year. Spring, summer, fall, winter, I play soccer all the time. That's the way I try to be active and do stuff. So as you can see, some of the open source symbols I put up here, I like to do, this is some of the things that I do in my spare time. And then I love sports, so Arsenal not doing so good. Spurs not doing so good. And then, I don't know if anybody is an avid NFL fan. I watch National Football League religiously on Sunday, and my team sucks as well, so that's why I shrink their logo over here. So I didn't do a good job. So that's a picture of my family, my wife, and my two little kids that keeps me busy every day. And these are the companies that I worked for. Central Mutual is where I work currently. And that's a picture of my alma mater, the university I went to. And of course, I had to represent a Phantom right here. So that's, in a nutshell, that's just me. So today, I hope that we can cover, data, enterprise data management, data warehousing, databases. I'm hoping that we can cover all these topics today. Now, how many of you here are IT folks? Oh, okay. So let me apologize to you guys in advance. I'm the least qualified person here to be talking about data or anything related to data, but I'll do my best to do you guys justice. So let me know how I do after this, okay? All right. So let's talk about data. And how do we really define data, right? So I have a picture of this here because of this. 2 months ago, my son was doing a homework. And, as part of doing his homework, he saw, he had to do the word graph. So he's like, Daddy, what is graph? And I said, well, a graph is a visual representation of data. Then he's like, okay, so what is data? I was like, these kids, they ask a lot of questions, so now I had to do some Googling. So I thought I would share what I discovered during my Googling. All of these words here really define data, right? It's information, knowledge, wisdom, and storage, right? I had to represent my computer science folks here, or they'll kill me. So, you talk about information, right? When you analyze the data, you extract information from it. And as part of extracting the information, right, the knowledge that you build by interacting the data makes you knowledgeable. And then by practically using the data, you gain some wisdom. And of course, when you come to computer science, data storage, binary files, symbols, characters, and so forth. So I wanted to talk about, some of the known accomplishments with data that most of you, or most of this stuff, people already know about this, right? Germany in 2014 used data to really help them win the World Cup. And it wasn't so much about the data. Of course, you need a skill, right? You need a teamwork. You need to work together as a team. But it also helps if you have some information to help you make good decisions on the field. So they were using SAP HANA, collecting data on videos, on the players, statistics on the players, and in every match, they had information about the team that they were playing, so they were very well prepared, and which helped them. And actually, SAP uses that as part of their marketing tool. Politics, a lot of people are now, especially in the States, they are trying to figure out ways to, target people, tap into their emotions to get them to go vote. In 2012, Obama used what they call micro-targeting to target people on Facebook and social media, knowing exactly what the profile of those people are and messaging them based on his policies to convince those people to vote for him. And then, of course, you have retail, Amazon, which is a big player, really, killing brick and mortar right now, retail, where they figured out how to optimize shipping, right? Getting things to people on time, recommending product to people that go on their website that, about things that maybe they haven't even thought about that they would want to buy. So I hope that, as part of my presentation, if you don't remember anything that I talk about today, I hope that we started discipleship here today, which is that people will care about data, and the people that interact with data at the various data points, you guys will educate them about, like the speaker said, the main speaker said, people that interact with the data sometimes don't know the value of the data that they are generating. And if you're an aspiring data scientist here, you're only as good as what comes to your desk or the data that you interact with. So I hope that you guys will care enough about data and educate people about the use of data, and it would help impact society. At least that's the least that we can do. So I hope that we learned that today. So let's talk about enterprise data management. So enterprise data, basically, you collect the data, you store it. Data could be generated internally, right? As a business, you have people interacting with your systems, or people who are using your systems to capture information. And so data is generated internally. That's, the data for the entire organization. And then you have, you can also integrate that data that you collect with other data sources. Working in the insurance industry, we tend to leverage a lot of external data, weather-related data, people's driving vehicle records, so we interact with the DMVs. We also work, we don't use social media data yet, but I know some companies use social media data as well. So those are some of the things that companies are using in addition to the data that they already generate internally. So enterprise data management, essentially what enterprise data management is, effectively moving your data across business systems within your organization, integrating the data with external data, like I said, emphasizing on the precision of your data, making sure that your data across all your platforms are accurate, they interact very well. And why is it so important to really manage your data? Can somebody, I want this to be interactive, so please, can somebody tell me why it's important? Sure.
Data he or she gets. So the data management is very important if you make quality data scientists who will solve quality problems.
Thank you. So one of the things is that, if you generate too much data, your data can get very, very, very overwhelming if you don't manage your data very well. Your data will be all over the place. And really, if you don't do that, this is what happens, right? You incur unnecessary expense because you would now have to pay a lot of vendors to now come and sell you their solution as to how you can organize your data or put your data together. And the value of your data, like you said, the value of your data diminishes. You can't really get any insightful information from your data. And I talk asymmetric information. I don't know how many people have economics background. From a macroeconomics perspective, it's a good thing, right? You don't want the patient to know more than the doctor. If the patient knows more than the doctor, then there's no point of a doctor, right? So it's a good thing. But in the case of insurance, you don't want your policyholders to have more information about more information than you, the insurer. It's not a good thing. So, for example, in the States, some insurance companies will ask the policyholder, hey, how do you use your vehicle? And they will say, for me, I drive 74 miles a day to work, and it takes me about an hour to get to work. Knowing that I drive a long distance and I'm going to go get an insurance, I can easily lie and say, because I know that you're not verifying that information, right? So I can tell you, oh yeah, I just do a 15-mile commute to work, right? And then knowing that I have more exposure on the road, I'm lying, I'm getting a better rate for my premium, but it's not helping the insurance company, right? So if the insurance company is smart, what they would do is they would have to tap into know my annual mileage, at least on average, how long I drive in a year. So if they know that, then they can price me accurately. So you, the business, should be at a competitive advantage than your prospective customers, right? So that you can be proactive in the way you do things. And so that's the reason why I put this over here. So the next is data warehouse. So basically, it's an environment where you're storing your system of records, right? And in this case, it's actually well organized. Big organizations, they will have multiple data warehouse, and I work for Nationwide, which is a big financial institution, and they have multiple data warehouses for different businesses, for different departments. So types of data warehouse, you have operational data stores, which is essentially where your live data sits. There's some integration there, but not a whole lot. And you're making operational decisions based on the data that is in this environment. Data mart, is essentially where you have your data organized in a way, or put in, you already write the queries, you've already put it together for like a particular department. So in insurance space, you would have a data mart just for underwriting, or you have a data mart just for actuaries for them to do like reporting. And then you have your enterprise data warehouse, which just serves the whole entire enterprise. In some cases, it could serve a department as well, or different organizations. So for a typical data warehouse schema, you have where the data is coming in. So your system of records is captured at the front end, and then you have your acquisition stage, where the data comes in. In between this, there's some ETL that happens. You extract the data, you load it, and you transform it. You have where the heavy integration, business rules, and things like that are checked, and business rules are checked to make sure you have to meet your essentially in this space, you're checking to make sure that the data is cleaned as possible before you put it into transform the data, before you put it into your tables and what have you. And then you have your BI, your business intelligence people interacting with the data, applications interacting with it, and also, at this stage, you can still have your data scientists still query, your database will be here in this distribution center portion of it, and then they can play with the data and interact with the data as they could. Okay, so the staging area, basically, that's your single source of truth. This is where all the data is coming in. You have, oops. You have your landing zones. You could have multiple landing zones, data coming in. There's barely a lot of transformation being done here. And then the data could have multiple staging as well. Then you have the data integration. This is where, like I said, business rules are validated. The data is cleaned and then mapped and compared and then combined. And then within the distribution phase, you have your BI schemas, you have your applications, and you have your database. So now let's talk about databases. Database essentially is an environment that allows all your systems, that allows data to be easily accessible, retrieved, manipulated, and updated. It contains tables and files, common types of databases. You have your relational database, which is one of the popular. You have distributed databases as well, which is basically distributed on multiple nodes. And you have your NoSQL database, which is becoming popular. But I thought, back in 2012 is when NoSQL database surfaced, and there was a big push for it. But I think that adoption has still not been as good as regular relational databases. I think part of it is because this technology has existed for a long time. People have adopted it, and so that's why you have more people using relational databases more so than NoSQL database. So data lakes is also another technology that is being adopted widely right now, and basically that's where the world is moving to, or most businesses are moving into. And that's because data science projects can get very, very, very complex. You need more data sources. The more information, the more attributes you can collect, the better, right? More data, the better. The more attributes you can get, the more your algorithms will do well. So in a typical data lake schema, you have your data sources, and then you have the lake. Inside the lake, your structured and unstructured data can exist there. All kinds, your data in its native form can exist in your data lake as well. And I put the ETL here and I made E and L bigger because there's minimal transformation that is done before the data gets into the lake. And that's because data warehousing projects tends to take a lot of time, where the IT folks are meeting with the business folks, they're getting the business specs, trying to put all of this together, and it delays. Some projects are not successful, and the data scientists are sitting there waiting to get access to the data. So people are now trying to figure out how can we make data quickly available to the data scientists so that they can interact with the data and not have to wait on IT projects to complete. So hence why the data lake adoption it's growing. So another thing I want to say is that so now instead of, when it comes to the data lake, instead of people saying ETL, people now say ELT. So you extract, you load, and then you transform it later. So the data, because the data scientists, you have the skill set, you have the tools to really transform the data and use it. You already have the skill set to transform the data as needed. To format the data in a way that you can fit into whatever algorithm that you're using. So I've said enough about a data lake. So it's a storage repository that holds large amount of data in its raw form. The data lake uses a flat architecture, unlike a relational database that is hierarchical. Element within the data lake is assigned with a unique tag. Data lake technology, it's not new. The technology it used to exist in the 80s. The problem with it is that data lakes became data jungles because, all the data is there. People couldn't figure out how to really extract the data. So now you have cataloging tools that have embedded in it artificial intelligence or some models in there to help you really, or algorithms in there to help you really search through your environment. And so I think Dremio is one of the open source catalog tools that are out there that people are using to really catalog or search through their data lakes. And then one of the things that has helped data lake to really evolve is streaming of data when people need to make real-time decisions. Because the ETL processes, and I don't know about folks in here, some ETL processes take a very long time. In certain organizations, some batch processes take 12 hours to run, or even days, and you need to make real-time decisions. This technology helps you to do that. So this is a typical modern architecture, and I borrowed this from one of the vendors that we were looking at from the company that I work for, where you have all the different data sources you can think of, and then you have the environment in here where you have your operational data store, you have a lake inside a lake, you have your database, and your analytical sandbox can also exist in that environment. This typical architecture is probably a cloud-based solution. I think there's a company out there called Snowflake that offers a cloud-based solution for data lake. And then you have the technologies and then tools that you can use to pull data from the lake. So data modeling and design. So the very common one is dimensional modeling. And in dimensional modeling, you have two keys. You want the ease of use. You want the business to really understand the database design should replicate what your business processes are, so that the people interacting with the environment can relate to it from a business perspective. So you want to make it easy of use, easy to understand, and not something complex. And then the query performance will be better. People shouldn't sit down and wait for data to take too long to render when you query it. So two basic part of dimensional modeling, you have the fact tables, which is capturing all your quantities and your sales, and then you have the dimensions, which is capturing attributes, at the customer level, in the case of retail. So database management systems, these are the popular ones, right? Personally, I'm not advocating for any of these. None of them paid for me to come here, so I'm not gonna push for any of these vendors. But they all work. They all have its pros and cons. The application, it's basically an application that allows clients and end users to interact with the database. The functionality of the application allows end users, this is what they call CRUD, right? Create, read, update, and delete. And the system accomplishes three key things. Manages database environment, manages the data, and then manages the database schema. And these three elements provide concurrency, security, data integrity, and uniform admin process. So data catalogs, I talked about data catalogs. Catalog It's basically a service that allows your end users to, it's a service that allows your users to explore the source and understand the data sources. Like I said, this is adapted if you're using this if you basically have a data lake in your environment. The entire use of a data catalog is that it's going to help you from a data governance perspective, which is another hugely growing area where there's a lot of employment opportunities. Companies are realizing that they need to govern their data, and data catalogs play a very key role in that as well. And it's very important from a data lineage standpoint because as a data scientist, you put together a data for a project, and sometimes, after doing all of that, pulling the data from multiple data sources and pulling the data together, you use the data, it fits your algorithm, but you still need to be able to store the data. And you can store it in a lake, which is great, but the cataloging helps you with the data lineage. Where did I pull this attribute from what table? So once you have all of that, it's easy to go back and look at that data. If you have to recreate and use parts and pieces of that data for another project, it's easy to use a catalog to understand the data that you have, and then so you can track the lineage of data for multiple analytics projects. So data governance, like I said, this is a huge growing area. If you think about, how many of you heard about the hot water that Facebook was in last year, right? They were in because of data breaches and how irresponsible they were with their data. They got out of bad publicity. But even beside that, they were getting a lot of flags, but Uber was even doing something even worse. And they were in hot waters as well. So Uber was working with another startup, and I don't remember the name, but that startup, what basically they do is that they provide you with a service to clean your email account. And Uber partnered with this company. They bought this company and they partnered with them. So what this startup does with the service that they provide, they have access to your email. So Uber had the opportunity to see what their competitors were rating, how they were charging their competitors, and so they were taking advantage of that, and they got into trouble for doing that. But because Facebook was getting all the bad publicity, that story went under the covers. A lot of people didn't hear about it. So with data governance, companies are realizing that data is an asset. You're good as your data, right? So you have to take proactive measures in really taking very good care of it. And in data governance, what you want to accomplish is, improve your data quality, put security around your data. And in some cases, especially for us in the insurance industry, we are very, very heavily regulated. Even your models are regulated. Sometimes I feel like I'm in grad school where, you have to send them, like your homogeneity plot. Like you have to send them all the things that you do when you're building your predictive models. Send all of them, your assumptions. It's ridiculous, but that's the nature of the environment that we work in. And again, in the insurance industry, they want to make sure that you're dealing with compliance. People's personal data is not being mishandled. And then, as part of data governance, you want to standardize documentation, which will help. You want to reduce risk and making sure that the right people are having the right access to the data, right? Especially in HR, where people's salary is and whatnot. Not just anybody can have access to see that data, right? So you put the right security around data that your organization generates. So I'll leave you with this question. I'll leave you. I'm gonna give you guys to give me time to. I'm gonna answer some questions, but I want to leave you with this quote from Edward Dems: "Without data, you're just another person with an opinion."